solving other types of equations. So let's review what types of equations we have solved thus far. First, we have solved linear and quadratic types of polynomials, where polynomials look like this here, that string or sentence of mathematical expressions. Remember, all of these A's are numbers or coefficients, and then the x's to the exponents are in descending order. So an actual example of this might look something like 15x to the 6th plus 3x squared minus 4x plus 2. That is an example of a polynomial. The ones that we have learned how to solve so far are degree 1, which are linear polynomials, and we learned how to solve those back in week 6, assignment number 1, where we isolated the variable. And the other type of polynomials that we have learned how to solve at this point are degree 2 or quadratic polynomials. Now, we have learned lots of different ways to solve those quadratic polynomials. Those involve factoring, quadratic formula, the square root method, and not to mention completing the square. So you can use your favorite method when you see a degree 2 or a quadratic equation. What we have yet to solve is higher degree polynomials. So how do we solve it when it's degree 3, 4, 5, so on and so forth? And so that's what we're going to focus on right now. The steps of solving those higher polynomials are actually the exact same steps of the factoring method when we solve quadratic equations. So first we set one side of our equation equal to 0, and remember the other side we went in descending order. That makes our step number 2 of factoring completely easier. Once we have it factored completely, we use the principle of zero products, which said, if we have something times something equal to 0, then either A equals 0 or B is equal to 0. So if you can put it in the format of multiplication to equal to 0, then you just set each factor equal to 0. After that, you solve what you have left at that point, and don't forget to check your answers, or at least check that you have the correct number of answers. Your degree, or your highest exponent on your polynomial, should be the exact same as the number of answers that you have. I have a couple examples here. My first example, 4x cubed plus 12x squared minus 9x minus 27 equal to 0. The steps are outlined for you at the top right-hand corner of your screen, and the answers are below that if you would like to pause the video and try this one on your own. Okay, step number 1 is set one side of the equation equal to 0, and in our problem, that is already done for us. So, there we go. Step number 2 is we need to factor completely. If we follow our factoring checklist, the first thing that we look for is any common factors throughout, and we do not have any. The next thing that we look for is the number of terms or pieces that we have. In this equation, we have 1, 2, 3, 4 terms. And the only way we know how to factor a 4-termed polynomial is to factor by grouping. So we group the first 2 parentheses and we group the last 2 parentheses. Then we look for common factors involved in those 2 parentheses. In the first 2, we have a common factor of 4 and x squared. So if we take that out, we're left with a positive x plus a 3. Remember, whatever your sign is here is going to carry down there. Then, in your last 2 factors, you have a 9 in common. So this is like we're actually factoring out a negative and a 9 all at once. That gives us a positive x and a positive 3. If you don't believe me, distribute that negative 9 back in, and you should get the same thing that you had up there. And we still have this equal to 0. Now, at this point, we have still two terms. This one here and this one here, separated by the minus in between. In between those two terms, we have a common factor. And that common factor is the x plus 3. And we can take that out, and we are left with a 4x squared from the first term and a minus 9 from the last term. And that is equal to 0. If this problem confuses you, then you might go back and watch the factoring by grouping video. Now we have finished the factor by grouping step, but we are not factored completely because our second set of parentheses is a difference of squares. It has two terms where a square is in the first and a square in the last. So let's copy down my x plus 3, and then let's set up my two sets of parentheses to factor that 4x squared minus 9 into. Factors of 4x squared come from 2x times 2x, and factors from 9 come from 3 times 3. The signs of difference of squares are always one positive and one negative. Remember, those factor into what we like to call conjugates. Now, at this point, we are finally factored completely. So what we do here is we set all factors equal to 0. Since I have 3 factors here, I set each one of those equal to 0. So the first one, x plus 3, is equal to 0. The second one, 2x plus 3 equal to 0. And the last one, 2x minus 3 equal 0. So, finish step number 3, and now we can focus on step number 4, where we are down to linear or degree 1 equations. So we solve these just by isolating the variables. X plus 3. To isolate the x, we just subtract 3 on both sides. That gives me the answer of x is equal to negative 3. In my second one, I subtract 3 from both sides. That gives me 2x is equal to negative 3. And then to get rid of the 2, we divide by it. So that gives us the answer, x is equal to negative 3 halves. My last one here, I need to add 3 to both sides. That gives us 2x is equal to positive 3. And then to get rid of the 2, we divide by it. So that gives us the solution of x is equal to 3 halves. Notice this is a degree 3 equation, so we should have 3 answers, which we do. So our final answer here is x equals negative 3, negative 3 halves, and positive 3 halves. If it asks for the solution set, then we have those same numbers in the braces as our final answer. I am not going to fully check this, but if you would like to fully check it, go ahead and try that on your own.